talk about the electrochemical cell. Okay? Well, the general principle, first of all, is local equilibrium. Means, okay, eta, electrochemical potential is chemical potential and electrostatic potential. Summation of that, and then if you make a derivative of this potential, and that is going to be the force, and this one should be the zero. That is the local equilibrium, right? Okay, when we measure the electrostatic potential, let's talk about the, we know about the chemical potentials, okay? It is very much related to the concentration of the elements. And so let's talk about the electric potential a little bit more here. And let's see, this is a surface, and x equal to 0. Now, when we have, let's see, let me just go into the potential measurements directly. Now, this is a solid, and this is a vacuum. And say we have the potentials according to the surface. Surface has obviously has a different potential to the bulk, okay? And here the phi means electrostatic macro potential, okay? And in a vacuum, we are going to have some kind of potential psi here, and then psi is electrostatic micropotential. And this is the potential that we can actually measure from the outside of the solid, okay? And then it's going to be extrapolated to the surface, and this one is going to be extrapolated to the surface. And then let's say that is the phi alpha, and this is the psi alpha, something like that. And we call the difference here, from here to here, we call this a chi. Okay? And let me see. Yeah. The chi now is surface electric potential. Okay. It is impossible to measure surface effects directly. And here the surface effect means the dipole effect, surface charge, and surface stated related thing, and the dangling buns, etc., etc. Okay? That's mainly the surface defect, we should say. And inside the solid, we know the atomic is arranged in a regular fashion. We'll assume it's a single crystal. Then we see the potential is going to be periodic, such that, well, it should go something like this, right? So this average value, that is a macro potential. And this is the micro potential. Okay, let's see. When we surface effect, we have to say about the Debye length. And the Debye length is basically means Debye length is basically means the distance where the surface effect has an effect. Okay, a surface effect is effective. The lambda depth of surface charge effect and that is the Debye length. Okay, and that has been related with the dielectric constant and the concentration of mobile charge defects. Okay. And then that is scalar there. macroscopic local dielectric constant. And two terms should be noticed. One is galvanic potential. Difference. That is delta phi alpha. Okay, electrostatic macro potential extrapolated to the surface. Okay, that is the phi alpha. And the difference between those phi alpha is going to be called the galvanic potential difference, and volta potential difference is going to be psi alpha. And psi and phi are defined in the former figures, okay? And the phi is going to be psi plus chi. That has been shown in the former figures. Now let's see, if we have a situation like copper and two metals and another copper here, copper 1 and copper 2. Basically that is the same copper, so we don't have to say 1 and 2 here, okay? There is the electrical lead to measure something in between 1 and 2, okay? And we know that the electrochemical potential for any species is going to be represented with this equation, and the phi here is going to be psi plus chi, okay? Now for electrons, in this case, for electrons, in one material and two material, the electrochemical potential difference of electrons is going to be chemical potential difference plus Q two plus chi minus chi 2. Okay? And here the chi 1 and chi 2 is the same material. It's negligible. And here, wait a minute, let me, that is going to be, the chemical potential, because it's electric material, is negligible. So I think I have been talking about the situation that here the three and let me see, 2 and 3, and here 1 and 4, where 1 is equal to 4, and 1 equal to 4, and that is a copper. Then we have a situation like this. Is that correct? I don't think it's a. What we try to say here is delta psi electrochemical potential difference of electron is just nothing but the phi outside that we measure. So that should be I don't know. I confuse this. This is the conclusion that we want to see. We want to see the electrochemical potential difference between material 1 and 2, 2 and 3. And that is just the voltage, that the potential that we measure outside here. That's what we want to see. So I think this one should be 2. I don't know. Is that going to be 1 and 2?